So in this video, we're going to find the area under the curve of the standard normal to the left of 1.28. So in order to do this, the first thing I do is I draw a picture. What's in the middle? 0 is always in the middle here when we're talking about the standard normal curve. It's kind of an ugly standard normal. Maybe I'll do a little bit better. There you go. Okay. Now 1.28, that's on what side of 0? It's on the right side of 0. So z equal to 1.28. So what do I want? I want area to the left. Okay, so I shade to the left here. Area to the left is the cumulative area. So that's exactly what the table shows me. Okay, the number is the probability of area to the left. So what does that look like? It's the probability that z, any z-score that I find, is less than or equal to this cutoff point of 1.28. Okay, so what is that equal to? Well, we got to go to our table to find 1.28. So I go to my table, get rid of all this. Okay, so 1.28 looks, oh, that's 2.8. 1.28, I start at 1.2, so I find the 1.2 row. Okay, and then this 8 here is 0.08, so I go down, and what is it? It's 0.8997. 0.8997. So this area is 0.8997, right? Now, just for your own purposes, if you see a problem and it says find the probability that z is strictly less than 1.28, well, what's the difference between less than versus less than or equal to? The only difference is that the less than or equal to includes this equal to part here. But remember, probability equals area. And so the area under the curve at one single point, z equal 1.28, what is the area at a single point? That area is equal to 0. So this part is equal to 0. So what does that tell me? The probability that z is less than or equal to 1.28 is the same as the probability that z is less than 1.28. And this is true for any continuous distribution, which a normal distribution is continuous. Okay, guys? So no matter what, if you see the bar underneath or no bar underneath, treat it the same. That's the moral of the story there. Okay, there's no area at a single point. All right, there's no, if you think about area, you got to have some width, right? And so there's no width there. That width is 0. So no area. Now let's try another one. Instead of finding an area to the left, the cumulative, let's do the opposite and find the area to the right of the standard normal curve. So we've got this. First thing I always do is I always draw a picture. So you're going to have a picture and you're going to need to fill it out. What's always in the middle? 0. Why do I say that? Because if I'm dealing with a negative number, I'm on the left side of 0 here. So z is negative 1.21. Okay, and then what am I looking for? Area to the right, so I shade to the right. Okay, now I go look up negative 1.21 in my chart. Negative 1.2, and then 1. It looks like I'm going to get 0.1131. Okay, so 0.1131. Now, think about this answer for just a second, okay? 11% of that area, 11% of the curve is shaded. Does that even make sense? Does it make sense that we shaded in red 11% underneath? I don't think so. Why not? Because if I shaded right down the middle, right? If I shaded right down the middle, which is actually less than that, right? What do we know is right down the middle? 50%, right? So there's no way that all of this is 11%. What is that 11% really? Remember, the table gives cumulative area, which is area to the left. So that 0.1131 is truly the area to the left, which is exact opposite of the area I want to find. What do I know? Total area under the curve equals 1, right? So if this is the opposite of what I want to find, the complement rule, okay? So to find the probability that z is greater than or equal to, so all z values that fall over here greater than or equal to the negative 1.21, this is equal to 1 minus that probability, right? That 1.31 here. That's what the complement rule says. So this is exactly the opposite of 1 minus the probability that z is less than or equal to negative 1.21, which is what that piece is right there. Okay? So when I do the math here, what do I get? I get 0.8869. So area to the right, I have to apply the complement rule. The complement rule says I do the 1 minus to get that area to the right. Okay? Now, finding area between curves. That's the only thing left we've got to do. So let's draw a picture. And I'm actually going to draw 3 pictures. And hopefully that's going to illustrate this better for us. Okay, so I'm going to take this picture. We'll copy it. And then I'm going to copy it one more time. Just like that. Okay. What's always in the middle? 0 is in the middle every time. Okay. Now, negative 1.96. So negative 1.96. Okay, negative 1.96, what does that look like? Okay, so that's right there. And then positive 0.5, that's just a little bit on the other side of 0. Now, what am I doing? I want to find this area between those two values, okay? So how am I going to do that? How am I going to get the area between those two values, right? Well, all I know is when I look these numbers up in the table, say I have the 0.5 here, right? If I do this in my table, the table is going to give me the area to the left here, okay? And then the table for the negative 1.96 is going to give me the area to the left here. Okay? So how do I use that information to get this desired purple area right here? How do I use that information? Well, graphically, I look at this right here. This one right here is more than what I need, okay? How much more than what I need? Well, it's exactly, if I subtract the one below it, then what do I end up getting? I end up getting this area right in here, okay? So I'm literally taking advantage of some geometric properties, okay? So really what I need to do is I need to find this blue area here. And then I need to find this red area here. And then I need to take the blue area and I need to subtract away the red area. And if I do that, then what am I going to get? I'm going to get the purple area right here. Okay? So let's see if we can't figure it out. All right? So what is that blue area first? Okay? So the blue area, well, the blue area, if I go look up 0.5 in my chart, so I go over and I find 0.5, so this is the row, and then 00, so it's the very first one, so 6915, 6915. So this is 0.6915, so that's 0.6915, all right? And then the red area for the number negative 1.96, so I go to, so for negative 1.96, I go to negative 1.9, that's right here. So this is the row that I care about. And then the 6 column, so I come down, and that's 0.0250. Okay, so this is 0.0250, so that little area is 0.0250 right in here, about 2.5%. Now, how do I figure out the area? I subtract the two numbers. When I subtract those two numbers, what do I get? I get 0.6665. Okay, so if you did in your calculator, so math points 6915 minus 0.0250, enter, 6665. Okay. So this area is the area between the z-scores negative 1.96 and 0.5, positive 0.5. All right. Now mathematically, how do I write this out? I would say I'm finding the probability that my z-score is between two numbers. What number? It's between negative 1.96 and it's between 0.5. So that's how I would write this out mathematically, okay? And so it's equal to the probability that the z-score is less than or equal to the 0.5, okay, minus the probability that the z-score is less than or equal to the negative 1.96, all right? And then whenever I calculate those numbers, that's where I get, excuse me, that's where I get the areas 0.6915 minus, and then the 0.0250. And whenever I get my final answer, it's the area 0.6665. Okay? So hopefully this shows you how to find. So truly all you're doing is you're looking up the z-score areas, okay? The quickest way to do this is to literally look up the areas for both of them. So I get an area here 0.0250 and I get an area here of 0.6915. And then I subtract the smaller one from the bigger one. Guys, if you subtract the two numbers and you get a negative number, just make it positive and you still get the answer. That's the quickest way to do it, okay? This way kind of makes you mathematically understand why it works the way that it does. Okay, so that's to find it between two curves. To find it for the for the right side, the area to the right of the z-score, you do the complement rule. And to find it to the left, you just use the number in the table, because the number in the table will give you cumulative area, which is area to the left. So that's the number that's already given to you. All right, well, good.